Hello everyone, and thank you for attending this new CATIA Dual Talk. Today, Daniel Pizak is back to present a very interesting capability about reverse engineering. Welcome, Daniel.
So thank you, by the way, thank you for all the people attending. It's always a pleasure to share with you the nice capability of CATIA in various areas. Today we will focus on reverse engineering. It's something that I already talked about in my previous CATIA Dual Talk, but you will see that new stuff are coming. So we continue to improve the capability of our solution in reverse engineering. And I will take some very nice examples, which is real life examples. And I will, at the end of my presentation, so stay up to the end of the presentation, I will disclose some capabilities which are not yet in the product, but will come very, very soon in 3D Experience CATIA. So let's start with the first scenario. We are in an airport, and suddenly the crew discovers that there is a piece of the plane seat for the passenger which is broken. It's not a critical part. It's not something which is, from a security point of view, super important, but it's something that we should change. Otherwise, it will be not very comfortable for the customer. So let's decide. Let's see how we can quickly replace the part. And unfortunately, in this particular case, there was no CAD model. So the maintenance guy from the airline company do not have any CAD model. So they have the broken part. And let's see how CATIA can help them to quickly reconstruct the CAD model from a scan of this broken part, print it, and replace this non-critical part again, and let the plane fly. Okay, so let's start. So this is my plane, designed with CATIA, and this is the piece, the part we would like to replace. Okay, it's in the business, by the way, business class. So you see the part, it's this red part. It's not very important, but it's needed. And we see here the part, and there is no CAD model. Okay, so not a problem. We have the broken part. Okay, this is the broken part. So what the maintenance staff on the airport can do is take the broken part. Unfortunately, they have no spare parts, but they have the broken part. They have no CAD model, so they scan this broken part. Of course, as it is symmetrical, they can replace the part which was damaged. This is a result of the scan. It's not really there are some imperfections due to the scan, but CATIA will help to reconstruct a CAD model very quickly. It will be a solid model, so we create some sketches. We enter into an app of CATIA which is dedicated to that. And after the design, we will be able to print actually the part on a 3D metal plastic polymer printer. So this is the part. You can here we compute the deviation between the part and what the scan model. It was good. It was acceptable. We print the part in the shop floor of the maintenance area of the airline company in the airport. This takes some hours, but not that much, and we can replace the part. So CATIA can be very helpful for maintenance, repair, and overhaul. Watch out, this cannot be done for critical part because, as you know, a critical part must be certified, the complete process. But it's quite helpful for non-critical part. Now let's go into the detail on how we did that, how we made that happen so quickly. We are in the app called CATIA Digital Shape to Surface. We are in 3DX CATIA. And we got this scan data of a prismatic part. So we have a dedicated wizard called Mechanical Shape Wizard to reconstruct a solid model, parametric solid model. Some not fully parametric, but you will see. And let's start. So we start by designing a so-called design space, which is a bounding box around the scan. So this is a wizard. The user will be guided by the wizard. So he has all the commands he needs in one wizard. He does not have to navigate in other menus. So first things he can do, he can select some area, and CATIA will recognize some canonical surfaces, plane, planar surface, cylinders, radius, sphere, torus, and he can help you to reconstruct all the surfaces which will be used to split the bounding box, the initial solid, and very quickly, I will speed up a little bit, you will be able to compute and reconstruct the CAD model. It goes quite far. It can recognize holes. It can create patterns of holes. It can recognize revolution. So very, very easily, you redesign. You see here on the left side all the features that have been created, pad, cylinders, stuff like that. And it's quite smart. Huh? You can do create a sketch. You can make some cross-sectioning. You can convert the cross-sectioning, which was a polyline, into a valid sketch very easily. You can here create oblong. You have feature hole. You can create the pattern of hole. So this is dedicated. So at the end, you will have a pattern inside the spec tree of your reconstruction. And finally, you can even make a user pattern with this pocket which has been done, cut out, and very, very quickly you can get the solid model. Okay. So now let's decide. Let me show you some new capability which was introduced recently. So let's imagine we have to rebuild again this prismatic part. Something which looks easy. It's not easy. What is a real plane and the direction of the normal of the extrusion or the pad that you will use? So in the extrude wizard, you select the face you would like to compute the normal of the plane from. Here we are. And you can easily create the sketch. Then you can extrude. And if I do the pocket, I do similar commands. Okay. So this is nice capability in the wizard. Something which is also important is to find a symmetry plane. You know, when you get the scan data, you can see this part obviously symmetrical, but you don't know exactly where is the symmetry plane. Okay. So we have a dedicated symmetry plane recognition. If you do that manually, it probably takes 20, 30 minutes. Okay. So just to find out the right one. So what we select this symmetry recognition feature. We select the cloud, the scan data, and we select a plane which looks like could be the symmetrical plane. So something's close to. So here it was one of the YZ plane. And then CATIA will compute the deviation between the one part and the mirrored one. And then it will optimize the position of the plane to reduce this deviation to a minimum. And at the very end, I will have a good estimation of what will be the symmetry plane, and I can start my work of reconstruction. Again, looks easy, but it's very, very helpful. It does in seconds what you probably need, as I said earlier, maybe 20 to 30 minutes to do. And this part is not so complex. Sometimes it's much more complex because it's completely freeform. Okay. So again, we have very, very automated capability in CATIA Reverse Engineering, but we have also simple stuff, simple command to do tedious tasks. Okay. That was for the mechanical surface. Now let's say you have to do maybe it's a plastic housing inside a car or also inside a plane, and it's broken, and you would like to have something clean. In this case, it's no longer a prismatic part. It's more a surface model, and we use for this a dedicated wizard called Curve Network Preparation. Let's start. This is a cloud of points, which is its tessellation. It's an STL file. You go, and what you do is you draw curves. You draw curves directly on the cloud, which can be a fictive edge in this case. And you create all your curves. You can also ask CATIA to compute characteristic line on the cloud. And you check at any time if your curve is far away from the cloud. By default, it's projected on the cloud, but it can be also an offset, especially when it's a fictive. The fictive is not in the cloud because it's the intersection of the two big surfaces, and you just have the fillet. Okay. So you continue to do the job. You create all your curves. You can use this display that I like very much. It really shows the difference between small fillet and large slab surfaces. You do all here. This is a characteristic line recognition, and then you create your curve. And at the end of this job, you have a set of curves, and you create a curve network. And CATIA will ensure that all those curves are intersecting themselves, and they have a common tangent plane. And then you can use, once you have created all your surfaces, your curves, you create a surface automatically by creating big surfaces on top of or between all those curves that you created manually. This is what we call the sharp edge methodology to create a surface. And then if you have fillet, you can add your own fillet using the filleting capability of the surface modeling of CATIA. So that's one way. Another way, which is I like very much, you will see that the next one, just compute the deviation to see that we are very close to the mesh. Watch out, this is also associative. So if the cloud points is changed, your network will be updated automatically. Now let's take another one, another capability, which is called the fillets mode. Here we are no longer creating the sharp edge, so the intersection between the surfaces, but the fore boundary of, let's call it fillet or blend, okay? So you see what you are designing is 4 curves, which are, of course, projected on the scan, but it creates the boundaries of a future fillet or blend. We can use this type of display, which is a curvature display, to help you to identify the area which correspond to the fillets, and you create all your curves like that, which is a special type of curve. It's a set of 4 curves. It's not only constant radius, it can be a variable radius. And very quickly, you create the boundary of your future surfaces. Once this is done, like initially, you can create, you can blend them. You can blend those 4 curves together. It can be a blend between two sets of 4 curves, or maybe 3 sets. So it's quite powerful. This is again the creation of the characteristic line, and we are smoothing them because we don't need everything, but we are guided by the characteristic line location to be as close as possible and to preserve the design intent of the scan data. So you see here, and we will blend them. This is quite nice capability. We will connect all those 4 curves set. Let's call it fillets, but that's not really fillet. You can also modify the curvature of this blend. You can modify the position of the fillets and so on. So it's quite efficient. Again, the idea is to create a type of skeleton on the cloud, like a wireframe, metal wireframe that you put on the cloud, and it's just the boundary. And then you will use the same command that I used earlier with my sharp edge model, which is the network and the automatic surface reconstruction. It's very simple. Huh? It's very straightforward. It's not rocket science. It's manual but assisted, and you know that you can do the job. You will never be stopped. You can do every single construction. That's the beauty of 3x CATIA Reverse Engineering. And once this is done, I will skip that, but you can do the automatic surface command, which is also associative. Now, a more traditional way to do that, it's probably more if you want to really control the quality of all those big surfaces, which are very important. You will use the same CATIA Digital Shape to Surface app, and it will help you to first identify the big slab surfaces. First, he will segment he will try to find out area in the scan. You see the big one, and you see also the fillet area. If you have some, you can merge 2 fillet area or multiple fillet area, so you can help the system. You identify, but you say all those guys are fillets, which are here put in red. And once this is done, once this job is done, it will segment automatically the scan, and you will have multiple sub-scan in your spec tree that you can use individually to create surfaces. So it's very simple. Again, not rocket science, but the user is assisted to make cumbersome operation as quickly as possible. Once I have this guy, I will just create my surfaces. You see here all the disassemble, which is a mesh which has been disassembled in multiple sub meshes. And then I use a command called power fit to fit NURBS or Bezier surface on every single area. And then I will just have to trim and with a traditional CATIA surface modeling capability, and then make fillets between them and measure the fillet radius by looking at the deviation between the scan and the surfaces. So it's, again, very simple, but it's fast. and at the end, you do your fillet. Okay, let's continue to see what CATIA can help you to do in reverse engineering. Here we are. You see it's quite nice quality. Huh? If you look at the deviation, the deviation between the scan and the surfaces, it's quite good. Huh? Okay, and if you are not satisfied with the deviation, you can refit again by using either change the radius of the fillet because you did not measure the right radius, or fit better the surface to the cloud. Okay, let's take this example now. Oops, come on, baby. Okay, this is a big challenge. Don't try to use the curve network or the sharp edge or the fillet approach or the big trim stuff. You will spend your life to reconstruct the model. So for that particular type of example, it's of course a set of bones from the foot and it's complex geometry. We have a very nice command in CATIA called automatic surface. And you will automatically create for every single pieces of bone of this foot subdivision surface. So it's real curvature continuous surfaces. You see here the result. So you can of course, if they are closed, convert these subdivision surfaces into a closed solid. Now you can manage more and more constraints. The first one was very freeform. There was no constraints. We just mapped the subdivision surface to the mesh. But now we can add constraints, which is quite cool. Again, if you want to go very fast to make a quick prototype, maybe you would like to do a printed model very fast, and you want to control the tessellation of the model and not take the mesh as it is, you can force the subdivision surface autosurf to be bounded by curves that you are creating. And CATIA will create this surface automatically bounded by this either blue or pink boundaries. And you will see the quality is quite high. Huh? So it takes some minutes just to reconstruct this type of geometry. Here we are. You see, of course, we can finish the job by making a symmetry. If you want to do this type of geometry, if you have to create that very quickly, you can also use, again, automatic surface. But in this particular case, you will ask the CATIA to create regular patches, 4 sides and sometimes 3 sides, but most of the time 4 times. And you can see here that it's very, very quickly done. And then you have a surface model that you can use in CATIA. You can make an offset. You can create a thickness with a solid modeling. And you can also, if you want, control the position of those patches, okay? Like if you were controlling the ISO U or ISO V of a NURBS or Bezier surface, okay? So let's have a look. So CATIA will create for you a proposal of the so-called ISO curves. Let me show you that. Oops, go ahead. And then you will be able to modify, because if maybe this ISO curve are not at the right location, you can modify them. You can, and of course, the final resulting surface based on this ISO curve will be smoother or of highest quality. So you can control the automatic surface. That's the message that I wanted to convey to you. Now let's see something very new. It's so new that it is not yet in the product. Okay, we will deliver very soon something called CATIA mechanical part reconstruction. We are using AI, and this is a solid model. Okay, maybe a step file, and I will show you how it can be used for reverse. But it's a step file. You see in the spec tree, it's just a solid. Okay, and you go to this mechanical part reconstruction app. And you ask CATIA to try to convert this dead solid, dummy solid, into a parametric model, but fully automatically, not like I did for the reverse engineering of the mechanical part. Okay, so let's do it. What CATIA will do first, it will recognize all fillet, draft, chamfer. He will remove them from the part, but he will keep them somewhere in memory. And then he recognized all the features. He found out a lot of features, 34 features, okay? And he will then add again the fillet or the chamfer that he found. And this is a spec tree. You see all the fillets. You see all the parametric feature, pad, pocket, holes, and edge fillet. You can use the analysis reconstruction. It will tell you what it did, how many pad, how many edge fillet, and so on and so on. You can display them. And as you see, we converted a dummy solid, a step file, to a parametric model. You see the value of all the fillets that it did. And this is something quite cool. And I will show you how it can help also for the reverse engineering. Okay, so this is coming soon in 3D Experience CATIA in this new role called CATIA Mechanical Part Reconstruction. And you see all the parameter set with the fillets. Okay, now let's see. Okay, I did that and I want to print it. Okay, no problem. I will go to a DELMIA app, which is called Manufacturability Check. And in Manufacturability Check, because I want to manufacture the part, I will select my part and I have some criteria for additive manufacturing, and I have some criteria for programming, subtractive manufacturing, which is mainly NC programming. Okay, so I'm here only interested by the additive manufacturing criteria first, but I can use both. Okay, in this Manufacturability Check app. And let's you select some parameters. For example, what is the minimum wall thickness, the gap between faces, the minimum hole diameter that the printer can do. So it's really printer dependent. And once you have defined that, you will be able to run the check on the part. And DELMIA Manufacturability Check will show you every issues or every problems. For example, here in this particular case, the bounding box. So you selected a machine where the build tray and the volume of printing is smaller than the part. So there are some issues. So, but CATIA tell you that. Sorry, DELMIA can tell you that. Now you can check what is the minimum thickness. So maybe this is too thin and it will not be printed perfectly. The faces are too close and maybe this will be filled of powder. So you will not get the right near net shape product. You forgot, as a designer, you forgot some cavity which are inside, so powder will remain inside this cavity. So it shows you what are the internal cavity. It can also show you if you have a flat bottom in your holes, and flat bottom is not really nice in additive manufacturing. You prefer a conical bottom. And it will also tell you if your hole diameter are too small, because if they are too small, the material will aggregate and you will not get the hole. It will be full of material, okay? Powder will go everywhere. So you can check the manufacturability check. What I like very much is, as a designer, if I use this app, I will be able to go and continue my printing process and maybe find out what is the best position of the part inside the printer to minimize the number of support. So CATIA, DELMIA Manufacturability Check will tell you what is, will optimize the position and the orientation of the part inside the printer, and it will help you to find out the best position. And once you define the best position, it will compute something which is extremely important. What you see here in blue is the value of the section. Let's imagine this is the printing direction is the vertical. The part is oriented this way, and we make a cross section, a slicing, and for every cross section, we compute the area of the cross section, and you see here the variation of the area of each cross section. Okay, you see here the cross section in white, and you can see here the area. And why is it important? Because if the difference between the area of consecutive cross section is too big, like maybe here, you see if you go from here to here, this will trigger probably distortion in the part. So as a designer, if you can get a very smooth transition of the area of the cross section, you will ensure that your part will be manufactured right the very first time. So the designer may decide to do some design change that will help to reduce the cost of manufacturing of this actual part. That's why I think it's quite nice. Okay, now let's take another example. No, it's almost finished. Another scenario, okay? Yep, let me stop. Okay, this part is not a spare part, but in fact, I have a problem. This part is existing. It's a legacy part, but the part it's a metal part, and the metal part was made with an alloy, a special alloy, which is no longer authorized because it has some special ingredients, special molecule inside this alloy, which is no longer, maybe it's considered as dangerous right now. So we have to reconstruct the same model, but with another metal. Okay, let's do that. And we don't have the CAD model. It's a very old model, but it's very useful. It's well done. So let's see how we will do that. First of all, we go again in manufacturability check to, as I showed you earlier, to check if everything is fine. But we can also optimize the position of the orientation, like I did earlier, to check if there is no big gradient of area of sectioning. And now we have a dedicated set of tools in CATIA to help you to prepare the part for the additive manufacturing. So how it works? You select first, maybe you add another thickness to the part which will be surface machined. So you add another thickness. That's not a big deal, huh? But you can also add special geometry. You see here there is another thickness with a fillet because it's much better to stick to the build tray. But you would like to remove the powder between the build tray and the part. So you create some channel, and we created special power copy, which are distributed free of charge in the CATIA media. You can also remove some holes because they are too small, but you can also convert some holes into diamond shape or water drop shape, you see here, because this will avoid to have support inside the holes. So this is quite nice. And then it will be drilled anyway with a drilling machine. And once we do that, we go to the DELMIA Powder Bed fabrication. We select a machine. We have multiple machine vendors available in the platform. Let's select the form up from Additive, form up 350. So, and from that, we'll position the part on the build tray. You see here the recotter, you see the part, you see the build tray. You can define now the support because this part will need to be supported. You see all the area. You might have some area where you need some support, which will be very difficult to remove from on the shop floor. So what we add extra material to avoid this horizontal angle, and which will automatically remove the need of support. So you see here that when we update the additive manufacturing preparation, DELMIA will automatically remove the support because there is no more need for support. Here we are. And it disappears. And now that this is done, so we will not need to have, you see, it disappear. Now when we have that, you can add a label because maybe you need to put the serial number on this particular metal part. And then what you will be able to do, is to add maybe a coupon. It's very important to add, some coupon to check. You may add some other various coupons that will be used to do some stretching of parts, some measurement of the geometrical property of the part and mechanical property of the part. So on the build tray, we put not only the part. Now in DELMIA Powder Bed, you can do the slicing, so maybe 15 microns. You can also select how the part will be lased, so the trajectory of the laser, how much power is provided by the laser at every single point, what is the speed of lasing, what is the speed of the recotter, what is the temperature of the chamber. Especially in aluminium, we are usually heating up the build room before at 200 degrees. It gives a better solution, better result. Here you can show every single slice and the trajectory, and then you can export this information to the form up Additive machine. And now we are in Additive Manager, and you double check that everything is fine in the software which is provided by the 3D printer machine vendor. Here we are. And then you print. You remove the powder. You extract from the build tray. You just, with a vacuum machine, you extract the powder. And then, because this is not a finished part, you go to the DELMIA NC Programming tool. Here, it's a mill-turn machining app from DELMIA on the 3D experience. Remember, it's fully associative. So if the part is changed, the NC programming, of course, will be updated, but also the additive manufacturing program will be updated. And here on my mill-turn machine, I just remove the supports, and I surface finish my functional areas. Here I remove again the supports, and I do my drilling. And very, very quickly, so 20 minutes to reconstruct the model, 20 minutes to prepare the NC programming, 20 minutes to prepare the additive manufacturing programming, and we have the complete part ready to go and ready to be used. And now let's stop it. Let me go here. Let's finish by a small live demo. You remember I will show you the new part mechanical reconstruction stuff, which is coming soon in 3D Experience CATIA. Let's see how this can be used in conjunction with CATIA Reverse Engineering capability. So the example is very simple. So let's make it like that. So up. Can I do that? Yep. Oh, sorry for that. Here we are. It's this guy I want to. Okay, here we are. Oops. Oh my gosh. Maybe I am not at the right location. Yes, sorry for that. Here we are. So I take the idea is very simple. The idea was to, oops, come on, baby. It does not want to go here. Oh, that's the problem of live demo. Okay. It does not want to copy my stuff. That's an issue, but it will come. Don't worry. I will continue to do the. No, he will not do it. But anyway. Okay, this is my file. Oops. And what I do is I just I have a standard parts that has to be reconstructed because this standard parts was just broken. So I went to the internet and I searched for a similar part. Here it's a pressure probe housing. So I found on some website a free shape of this pressure probe, and I just copy paste this data from the web as an STL representation inside CATIA. This is what you see on the screen. So I am here in CATIA Digital Shape Preparation, and I import the STL data. This is an STL file, okay? But it's not a scan. Huh? It's a quite cool and clean STL file because it has been computed by a tessellation of a CAD model. So it's clean. So what I do now, I go to, you see, it's really mesh. Huh? It's an STL file with triangles and all this stuff. What I do now, I will go to CATIA Digital to Shape application and use something I showed you earlier, but not very quickly. What you see, you will now ask CATIA to segment, to partition your STL file into multiple areas. So you find, planar surface, you find cylinders, you find torus, you find NURBS surface if it's a freeform shape, and you color that to show you what is the result. You can again aggregate some of them if the result was not good. Here in this particular case, you find a good segmentation of the mesh. And once I have that, I will convert this segmentation of mesh into a BREP, into a solid. So here I just say tessellation segmentation to BREP, and I have my, it's real time, it's not speed up. I have my solid, hopefully. Here we are. It's a CATIA solid. It's a dummy solid because it has no history, no parameters, okay? You see here, it's really a demi-solid. But now, thanks to what I showed you earlier, I go now to mechanical part reconstruction. I will use the same wizard that I showed you earlier. I click my solid to reconstruct. Here I will show you how we create the dress up. So I will recognize the dress up. So I click on dress up recognition. I will select the max value of the radius I would like to recognize. Looks fine to me. I defeature my demi-solid. And now I run this specific reconstruction tool. It will find out for me all the primitives, the features, the pads, the holes, the pockets. You saw that you found out 15 feature inside the spec tree. You can see it. Here, if you see here in the spec tree. I can use the reconstruction analysis to display all those features individually, or I can play with this video mechanism player, and I show every single step again. Once this is done, of course, I have something which is very helpful as well, is that CATIA reconstruct at the same time a skeleton. Okay, you see here the skeleton. This is done automatically, and of course, so it ensures that the part is well done from a parametric modeling point of view. You know, when you use a skeleton, you can drive much more easily all the design changes, and it's more robust in case of complex design changes. You see the skeleton. Of course, I can. This is also a parametric skeleton, huh? And I can, for example, take one of the plane and move it because it's a fully parametric model. Let's move it up. So I change just the offset value that was initially used for my part. I move it up. Come on, baby. Yep. So we reconstruct from an STL file a dummy-solid, but CAD model, and we reconstruct from the dummy-solid CAD model a fully parametric model. And now let's imagine I would like to make a library of such standard parts. I can create, it's very easy to do in CATIA, a design table or component family library. And I will be able to select the parameters, which are the driving parameters of my standard model. For example, here I will just click on the base size and show you the design table. And you can play and select the parameters you would like to change and let's say the configuration that you would like to use for your pressure probe very easily. And remember, I made that, it's real time, huh? Nothing has been speed up. So in less than 5 minutes, I was able to do that from an STL file coming from the tessellation of a CAD model grabbed in the internet. That's what I wanted to show you. Maybe I was a little bit slow, I don't know. I think I'm fine. Thanks a lot for your attention. It was a pleasure again to be with you. Hope to see you next time again to another topic. If you have any question, Anne, do you know if there is any question?
Yes, there is one, at least one. Someone wants to know how to contact you, Daniel. So
you can answer. You can answer.
Yes, it's true that normally we add your LinkedIn account directly in the LinkedIn event, and I checked that it's not the case yet. So we'll do this afternoon. Of course, you can join the CATIA user community and contact Daniel there. It will be easier, I think, to follow up. So let me remind you about that. So you can join the CATIA community by using this link, go.freedesk.com/CATIA. This is where you can also view all the previous CATIA user talks and jewel talks presented by Daniel. And let me check again. I think I have another question for you, Daniel.
Go ahead, Anne.
Yes. Was this capability already available in CATIA V5? Because I find it impressive, especially that this applies to any type of part. And also, it's amazing that because it looks that we can reconstruct all the specification tree automatically. So can you tell us more compared to V5?
Yeah, what I showed you for the automatic reconstruction of features is coming soon in 3DX CATIA. It's not in V5. Most of the stuff I showed you, V5 is quite decent. It has very nice capability, digital shape editor, quick surface reconstruction. You have dedicated app for do reverse engineering in V5, but it has not the same, let's say, order of effectivity or efficiency that what we are providing in 3DX. So it was a good solution. It is used by many customers. 3DX is also reverse engineering is also used by many customers, but it's much more powerful, to be honest. So I really encourage you, if you are using V5, to look at least at 3DX, and you will see there are big differences. And by the way, just for information, we have many customers using our reverse engineering tool, either V5 and 3DX, more and more on 3DX, of course. From many industry, it applies to aerospace, it applies to transportation and mobility, consumer good, home and lifestyle, energy and material, life science. Almost every single industry need at a given time, by the way, more and more, to get a scan data from a legacy model, from a physical prototype, from a mock-up, and so on and so on. It's like a Swiss knife. You can really select a small subtool in your Swiss knife, depending on the challenge that you have and the use case that you have in front of you. But I can ensure you that not only you can do the job fast, but you can also get very high quality results in terms of let's say the quality of the model, geometrical model. I really recommend you to have a look if you have, of course, needs for reverse engineering and if you have needs for doing spare parts on demand.
Great. Thank you very much, Daniel. Just a few words to conclude. So if you have other questions coming to your mind, don't hesitate to go to the CATIA user community. For this, you can flash this QR code that you see on the screen or enter the link below, go.freelance.com/CATIA. You'll have to create a DS passport. It's very quick and easy. And once you log in, you access the CATIA user community, you'll see that there is a lot of content such as other demo videos, blog posts, questions, and so on. But you will go to the wiki section to find the CATIA Talks program and this specific CATIA talk. That's where you can continue asking questions to Daniel in the post comment section. And also, if you have comments about what you expect from CATIA on reverse engineering or other topics that you want us to cover, don't hesitate to add them. And yes, Daniel, Mr. Samuddin wants to also reassure you, you were not slow, you were excellent, he said. So thank you very much. Thank you all for attending and for your questions. And thanks, Daniel. Goodbye for now.
Yes, thank you, Anne, and for your support, and thank you all the people who attended. I wish you a very great end of day, beginning of day, whatever region of the world you are. It's always a pleasure to be with you. It's always a pleasure to share. The good news for me is that there are so many new stuff coming, CATIA, every single year that I will probably continue this for a long time. So thank you very much, and have a great day. Don't hesitate to ask questions, and bye-bye.
Bye. Thanks.